The third section of sugarcane processing is evaporation. The main purpose of evaporation is to concentrate clear juice of around 12 degrees Brix by removing water with the aid of exhaust steam, vapor, and vacuum pressure, transforming this clear juice to syrup of around 60 degrees Brix. The main reason why clear juice is concentrated is to obtain a saturated solution. Saturated solution is a solution in which no more solids can dissolve at a certain temperature. Hence, at this point, crystals can be formed. In early industry, evaporation and crystallization were done in open pots. Later on, around 1830, sugar industries moved to multiple effect evaporation systems. In this system, evaporation is done in two stages. Initially in evaporators to concentrate clear juice, later on in vacuum pans to crystallize sugar. The main idea of this system is to use vapor produced in one evaporator to heat material in the next evaporator. This system can have around 5 to 6 evaporators. Clear juice from clarifier is first heated in heaters to raise its temperature to around 110 degrees Celsius. Later on, it's taken to evaporator 1. Exhaust steam from powerhouse is used to heat clear juice in evaporator 1. Vapor produced from evaporator 1 is taken to evaporator 2 to heat materials in this evaporator. This heat transfer process continues up to the last evaporator. Vapor produced from the last evaporator is used in condenser to create vacuum. Excess vapor from evaporator 1 to 4 can be used in heaters at juice treatment section. Remember, I discussed the reason why we heat juice in juice treatment section. If you want to get more information, kindly watch the video that I uploaded a few days ago. As steam and vapor transmit heat to the juice in tubes, it is transformed to liquid form called condensate. Condensate from evaporator 1 and 2 is used at boiler to create live steam, while condensate produced from evaporator 3, 4, and 5 is used at pan boiling section and milling section as imbibition water. For the multiple effect system to work efficiently, the industry must obtain temperature differential. This is attained by using vacuum in the last 3 evaporators. Vacuum lowers the atmospheric pressure of the vessels, hence lower the boiling point of the materials. So the materials can boil even if the temperature of 100 degrees Celsius is not attained. Temperature of the vessels vary in descending order, i.e. evaporator 1 has a temperature of around 120 degrees Celsius. Evaporator 2 has around 115 degrees Celsius. Evaporator 3 has around 95 degrees Celsius. Evaporator 4 has around 85 degrees Celsius. Finally, evaporator 5 has around 65 degrees Celsius. Evaporator 1 and 2 use high temperature to remove water, while evaporator 3, 4, and 5 use temperature and vacuum to remove water. Vacuum pressure in evaporator 3, 4 to 5 is 550 millimeters mercury, 660 millimeters mercury, and 760 millimeters mercury respectively. Evaporation temperature has to be maintained between 125 degrees to 65 degrees Celsius. This because if this juice is heated above 130 degrees Celsius, sucrose can decompose, hence reduce the sugar content of this clear juice. While temperature below 65 will force the operator to raise vacuum. High vacuum pressure is not recommended because it can lead to entrainment. Entrainment is just the presence of juice droplets in the vapor. We will see at the end of the video the reason why entrainment is avoided in evaporation section. Juice with temperature below 65 degrees Celsius is viscous, and a highly viscous syrup is hard to pump and also will affect heat transfer in pan boiling section. Use of multiple effect system is advantageous to the sugar industry because exhaust steam from powerhouse is only used in evaporator 1. The vapor produced in these vessels are used in juice treatment section, hence reduce the use of exhaust steam. Also, in this system, the material is handled at low temperature, hence prevent caramelization. Most sugar industries have moved to the use of rising film multiple effect evaporation system, whereby material is fed to the bottom of tubes where it's heated by vapor or steam. As vapor is formed in this juice, it rises up carrying the material as a thin film against the tube wall. In the vapor body, vapor and concentrated material is separated. Concentrated material is taken to the next evaporator by the outlet valve. Material from the last evaporator is known as syrup. Recommended brix for syrup is between 55 to 60 degrees brix. Syrup below 55 is not recommended because more time of evaporation will be needed at the pan boiling section, while brix above 60 will lead to formation of crystals, and formation of crystals in the evaporator can block tubes and also will cause a problem in pumping of this syrup. So for the operator to maintain this brix range, he or she has to observe the following. Number 1, the initial brix of material. If clear juice has brix below 12 degrees, it will need more time for evaporation. So the material has to move at a slower rate. Number 2, the condition of the vessels. Scale during heating, the minerals and other substances fall on the surface of the evaporators, forming scales. So if the vessel has more scales, there will be low heat transfer. The scales can be removed by brushing or use of sodium hydroxide and hydrochloric acid. Next is the volume of the material in the tubes. The material has to be fed to the third of the tube for efficient boiling. So the operator should regulate the amount of clear juice being fed to the first evaporator. Next is the vacuum and steam used. The recommended exhaust steam to be used is between 0.5 to 1 kg per centimeters squared. In case this steam is high, there will be high caramelization, and if it's low, the syrup produced will be of low brix. So finally, let's see the parts of the evaporator. Number 1 is saucer. It's a round bottom cone whose function is to feed material to the evaporator from the main feed valve. Number 2, we have calandria. Calandria has stainless steel tubes. This is where heating occurs. Material is fed to tubes which are surrounded by the steam. Number 3, we have vapor body. Vapor as material heats in the tube, it moves upwards with the vapor. As the vapor is separated from the concentrated material. Remember, the temperature of vapor body is almost 10 degrees lower than the temperature of calandria. Number 4, we have vent. The function of vent is to remove ammonia and other gases in the material. The reason why these gases are removed is because the presence of this gas can affect heat transfer. Next, we have condenser. This is an enclosed vessel whereby the cold water meets with vapor to create vacuum. Next, we have entrainment separator. I informed you earlier, entrainment is the presence of juice droplets in the vapor. So the function of entrainment separator is to remove juice droplets. Juice droplets are removed from the vapor because, number 1, the condensate from evaporator 1 and evaporator 2 is used in the boiler. So the presence of sugar in this condensate can cause severe damage of boiler. Number 2, presence of sugar in the pipes that transport vapor to condenser can lead to formation of acids which can corrode these pumps. Number 3, presence of juice droplets in the vapor can lead to undetermined losses. Finally, we have view glasses. The operator uses these glasses to observe the boiling and the level of materials in the evaporator. So we have obtained syrup. This syrup is pumped to pan boiling section. In the next video, I'll cover pan boiling as the 4th section of sugarcane processing. Thank you very much for watching my video. I hope you learned something from this video. If you've not yet subscribed to my channel, kindly subscribe to my channel so that you can get more videos. And for those who have already subscribed, thank you very much. God bless you.